How it works, pneumatic piston. So the basic concept behind this pneumatic piston is you have two inlet channels. So compressed air at 95 psi is pumped through channel 1. This in turn drives the piston forward. The force produced by this will be the pressure of the air times the area of the piston. Compressed air at the same pressure is pumped through channel 2, driving the piston backwards in the negative x direction. Calculating the piston velocity. In order to calculate the piston velocity, we first measured the change in distance of the platform. The slow motion footage was analyzed to find how long it took for the platform to fully extend. The start time was 1.633 seconds, and the end time was 1.867 seconds. The frame capture rate in the slow-mo footage was 200 frames per second. This is 10 times slower than the normal 24 frames per second. So in the velocity calculation, the change in distance over the change in time was divided by 10 to account for this slow frame rate. The velocity was calculated to be 9.36 millimeters per second. Developing a dynamic model. In order to develop a dynamic model for this system, we need to measure a few variables. The first one, according to the pressure gauge, the pressure going into each nozzle was precisely 95 psi. Next, the area of the piston had to be calculated by estimating the diameter of the piston. The third measure variable was the mass of the platform. To develop the equation of motion for this system, we simply used the conservation of mass, which states the mass flowing into a system has to equal the mass flowing out of a system. Using Newton's second law and the conservation of mass, the following equation for motion was found.